In this example, we want to solve this log equation. Log base 2 of the quantity x plus 7 equals 1 minus log base 2 of the quantity x plus 8. So because the entire thing is not all logs, we can't just take the arguments and set them equal to each other. So if you don't have just a log equaling a log, usually what you want to do is get the logs on the same side. So I'm going to add log base 2 of the quantity x plus 8 to both sides so that we can isolate this constant here. So when I do this addition, I end up with log base 2 of the quantity x plus 7 plus log base 2 of the quantity x plus 8. All of this equals 1. Now what's really nice about this is we now have two logs with the same base on the same side that are being added together. This addition tells us that we can actually put these both into a single log. We can express this expression on the left as a single log using the product property of logs. So the product property says that if you have two logs with the same base that are being added, you can put the arguments together through a product. So when we use the product property, we end up with log base 2 of the quantity x plus 7 times the quantity x plus 8. All of this is our argument there, is equal to 1. Now, in order to solve this, we need to get the x's out of our argument. So we actually probably want to take this and switch it into exponential form. So we're going to take this log equation and change it into exponential form. So remember, when you're changing from logs to exponential, the base of your log is the same as your base of your exponential. So the base is 2, so it's 2. It's going to be 2 to the first power equals this whole argument. 2 to the first equals x plus 7 times the quantity x plus 8. And now, in order to solve this, we need to FOIL and expand this binomial multiplication and solve a quadratic. So x times x, that's going to be x squared. So 2 to the first is 2. X times x is x squared. X times 8 is 8x. 7 times x is 7x. 8 times 7, that's 56. So we end up with 2 equals x squared plus 15x plus 56. And then subtract 2 from both sides, and we have that this quadratic equation. Whoops, sorry. X squared plus 15x plus 54. So now we need to factor this and solve. So this factors to be the quantity x plus 9 times the quantity x plus 6. Set each of these equal to 0, and we end up with x equaling negative 9 and x equaling negative 6. Now, if you recall, the arguments of our logs must be positive. So we have to check these answers. If I take negative 9 and I plug negative 9 in for x, negative 9 plus 7, that's negative 2, and negative 9 plus 8, that's negative 1. So negative 9, x equals negative 9, is not going to work. This is not a valid solution for our log equation. But if I plug in negative 6 plus 7, that is 1. And then negative 6 plus 8, that is 2. So this should work. This should work. So our only solution is going to be that x equals negative 6, because 9 makes the argument negative for each of these logs.